Problem number 5 states, in triangle ABC, angle A equals angle B equals 45 degrees, and AB equals 16. Mutually tangent circular arcs are drawn centered at all 3 vertices. The arcs centered at A and B intersect at the midpoint of AB. Compute the area of the region inside the triangle and outside of the 3 arcs. So here we have the given information. Angle A equals angle B equals 45. From that information, we can conclude this is an isosceles triangle, and it's a 45, 45, 90 triangle. We also know that AB is 16, and with this information given down here, that arcs A and B intersect at the midpoint AB, we can also determine that these 2 lengths here both equal 8. Also, we know that mutually centered tangent circular arcs have their vertices at the center of each of these circles, which you can kind of see drawn here in the blue. So the first thing we have to do in this problem is find the sides of legs AC and CB. So we first, since we know that it's a 45, 45, 90 triangle, it's equivalent to the 1, 1, root 2 triangle. So we take our hypotenuse, 16, and divide it by root 2, and then you just have to rationalize the denominator. So multiply top and bottom by root 2, and you get 8 root 2. So we know that this is going to be the side here and the side here. The second step we have to do now is find the areas of this triangle A and this triangle B. And the way we do that is we use the area of a circle formula, which is pi r squared. But since we're only interested in this part of the circle, we also we only account for the 1/8, since this is 45 degrees, which is 1/8 of 360 degrees of the circle. So we know that our radius is 8 from this information given here. So we take pi 8 squared times 1/8, since we're only counting for 1/8 of the circle. And when we solve all this, we get 8 pi. So we know that this area in here and this area in here are both 8 pi. The next thing we have to do is then find the area of C, which is this region down here. So we go about the same process. It's pi r squared, the same formula. And this time, since we're only looking for this little part here, and we know that the radius is 8, what we do is we take our side, which is 8 root 2, and we subtract 8 from it so that we get this little portion here. So that's our radius of that circle. You square it, and this time we're taking 1/4 of the circle because this is a 90-degree angle, which is 1/4 of 360 degrees. So since that's the quantity squared, you have to write out both quantities and FOIL it, multiply by 1/4, and when you simplify that, you get 48 minus 32 root 2 quantity times pi. So now the next thing we have to do, since we have all these 3 areas, we need to find the total area of the triangle, and then eventually we'll subtract out this region here. So the way we do that is base times height times 1/2. And here you have base times height, they're the same, base times height times 1/2. Simplify that and you get 64. So the whole area of the triangle is 64 units squared. And then the last thing we have to do is then find the area of this region in here. And the way we can do that is take the area of the triangle and subtract out each of these regions, which we found here previously. So do that by 64 minus the quantity of 8 pi, which is here, plus 8 pi. And then you want to add in the 48 minus 32 root 2 times pi. You simplify all that, and you get 64 minus 64 pi plus 32 pi root 2, which is the final answer of this region in here.